welcome to this session on what's just in noteworthy features in Java and Android. So I'm Rama Chintapalli and my colleague Tyler. We work on the Android and the Java team. So we'll go through some of the new features that have been released in the SDK. So we'll go through some of the samples, how to use them, and a little bit of code. Okay. So what did we have new in runtime? So this may not be very specific to Java and Android only, but some of these features are also part of the runtime in general. So we have dynamic feature rendering mode, which is kind of a new rendering mode for our feature layers. We enhanced that. We also now support the OGC layers, WMS, WMTS, geo packages as well. We'll see that. We also support the Shapefiles. We'll see those. And there's analysis support that we added for 3D that includes view shed and line of sight. We also have introduced transactional editings to geodatabases, which is new. And then on the offline map, like we have some pre-planned workflows that we released recently. And finally, so there is Kotlin support for both Java and Android. So with that, we'll not have any more slides. We'll just go through all the demos and probably the code. Okay, we'll start with Tyler.
All right, I'm going to try to use this mic. So the first demo that I want to show is on the dynamic feature layers. So this is just kind of a small improvement, but a pretty significant one. Oh, sorry.
It should be on that. So we haven't switched. No?
It was on your screen.
It's pretty weird.
Okay.
So maybe while Tyler is working on that, maybe let me switch to my machine and show some of my samples.
That sounds good.
So that we can give some. So maybe there is a loose connection there. Okay, so let's see some of the new stuff in Android. So let's start with geo package. So now we started supporting geo packages. So geo packages is like an open source format for keeping both the raster as well as the vector data. So when you load this feature layer is actually loading the vector data. So we'll see the code through it, like how the geo package is loaded and how you can get the vector information from that in this particular sample. I'll switch to the presentation mode so that you can see better. Okay, so if you see the code, like you can see that, like you can give the path of the geo package, and there's a geo package class where you pass in the path to the geo package and load. Since all objects in runtime follow the loadable pattern, like you load the geo package class, and once the load is complete, you can actually get the feature tables from the geo package. So in this case, like there's only one layer, so we are getting one geo package feature table. So once the geo package table is available, so we just pass it to the feature layer class, and the feature layer is added to the operational layers as an layer. So by calling map.getOperationalLayers and add feature layer. So So that has just loaded the GeoPackage feature table. And if we go back to the raster, so it's the same piece of code. Like again, you load the GeoPackage. You can also have these raster files part of the GeoPackage. So in the previous example, we got from the GeoPackage, we got the geodatabase feature tables. Now for raster, we should we have a list of rasters that you can get from the GeoPackage. So if you see the code, it's pretty much the same as what we saw for the vector data, except that now from the GeoPackage we are getting the GeoPackage rasters. Again, as I mentioned, like you can have any number of rasters embedded into a GeoPackage and any number of vector tables as well. So that's part of one of the parts. Maybe like I'll continue all my samples and then we'll switch to Tyler's. Okay. So there is also support for feature layers from Shapefiles. You can see that like by default, Shapefile or the GeoPackage feature tables, by default they don't have any symbology or rendering. So like they are rendered with a default symbol. So you can always go to the layer and change the symbol type. But as I mentioned, it's similar pattern. So in the case of Shapefile, like you create a Shapefile feature table. In the case of GeoPackage, we created a GeoPackage feature table. For Shapefiles, we create a Shapefile feature table. So let me get the piece of code. So if you see the code, it should just look exactly similar to the GeoPackage code, except that now the table is actually coming from a shapefile instead of a GeoPackage. So the next feature, we also supported another OGC layer type, which is a WMS layer. So this layer is coming from USGS. It does take some time to load because of the network bandwidth, but while it loads, let me just quickly go to the code of this layer. Again, it's a new type of layer. And you can see like, so you provide an URL to your WMS server. So this is an open source format. So, and also Esri has its own WMS services too, like you can publish it through the desktop. So you pass in, give that URL and mention which layers you want to add to your, that you want to view in your layer. Because WMS itself has like a lot of layers in it, so you can specify which layers you want to include, and then again you add to the map as an operational layer. So let's see if it is loaded. So yeah, like the WMS layer that's coming from USGS is loaded. So the next feature I wanted to show was on database transactions. So there was an issue with the emulator, so I actually recorded the sample for database transactions, which works fine on a device, but there is some issues with the emulator. So let's see this sample. So here is a simple sample where I load a geodatabase. So previously for offline or data collection, you can see that I'm adding multiple points while collecting data to my offline geodatabase. And after certain time, I decided, okay, for some reason, I felt like the data is not correct. So I have an option to roll back. So I can revert it by doing an undo that would clear all my data collection till that point. And then I can start my data collection again fresh. And I can collect more points and then finally commit it. So what is happening behind the scenes is this was one of the requests from you guys, that you wanted this option to roll back features while editing if you are unhappy with the data collection. So now whenever you want to do data collection, you can use transactions. You can start a transaction and do all your edits as part of that transaction, and then if you are satisfied with the data that you collected, then you can commit to things to your database. And if you are not happy with the collection part, like, you can always roll back your features, and it will remain in get back to where you started. So like if you see the code for it, it's pretty straightforward. Like there are methods on the geodatabase class, so you can check whether you're in a transaction or not. And whenever you start editing, you can see if you're in transaction. If you're not in a transaction, you can begin a transaction on a geodatabase, and the editing is same as how you used to do before. Like from the geodatabase, you get the table, and on table you can add features or delete features. But the new methods that were added as part of this API is geodatabases can now roll back the transaction. So like if you felt like the edits that you made were not good, or for some reason you want to roll back, you can now call geodatabase.rollback, and that would roll back a transaction. Similarly, like if you want to commit your edits, you can call geodatabase.commit transaction. One thing to keep in mind is whenever you're working with an offline geodatabase and you want to sync things, you make sure that you commit your transactions and then perform the sync. So if you are already in a transaction and then you try to perform a sync, you will get an exception saying that the database is already in a transaction, so it will not let you sync things. So you have to commit your stuff before trying to sync your geodatabase. So that's so the next feature I wanted to show is like the offline map task now has a new capability to download pre-planned workflows. For example, this particular app, so you just pass a portal item and you order this pre-planned map areas in an ArcGIS portal environment. And once you pass that portal item to the offline map task, like it now knows what are the pre-planned map areas that are authored already in the portal. So for example, this one is actually getting all the pre-planned map areas, and it's showing us which one to download. So these are all pre-cooked map data that is part of your organization. So somebody has authored it for you, and from the client side, you're just trying to download that. This would greatly increase the download times. Previously, if you had to take the whole map offline, you had to like export the tiles, export the vector data, and then package it. So this one should directly get the data from already authored pre-planned maps. So this would download the map offline, and then you can see that it's much quicker because this is a pre-authored data in your organization. So if we see the code for it, So you can see that offline map task is constructed by passing the portal item that you want to take offline, and from the offline map task, like you can get all the pre-planned map areas that somebody has authored for that particular portal item that is available in your organization contents. So from that you get all the list of pre-planned areas that are available. So that's the list that we saw in the demo. And once the list is available, you select one of them, one of the pre-planned map areas, and then download and call this method download pre-planned offline map, and you pass the map area, pre-planned map area, and the path you want to download, and then just start the job, and that will download the map for you. So yep, those are all the things that I had demos on Android side. Let's switch back to some of the Java samples.
Okay, great. All right, looks like it's working now, so that's good. First thing I wanted to show, we mentioned feature layer rendering mode. We now have a dynamic feature layer rendering mode, which this is really kind of a small improvement on a feature we already had, but it's actually pretty significant. Here I have our sample viewer, which you can download off our developer site, and we actually have a sample that demonstrates the difference. So at the top we have the old feature layer renderer, and then at the bottom we have the new dynamic feature layer rendering mode. So you actually notice that the rendering stays pretty sharp and you don't lose things as you're zooming in and out. Yeah, overall it's just a lot better quality and it handles that zooming in better. So again, small improvement, but it makes your apps look a lot better. And it's very easy to set that up. Essentially all you do is call one thing to call it the rendering mode to dynamic, which is done right here. So that's that. Rama also mentioned he did WMS. We also support WMTS. It's very fast. If we look at the code, it's pretty similar to making any other kind of layer. With WMTS, like WMS, the service endpoint is like an XML description holding all of the layers. We can actually dig into that through the API. So if you pass in that service endpoint, we get a WMTS service, and after it's loaded, we can get the service info and find the different layers in there and actually discover the ones we want. And then we have a WMTS layer class that we can create that layer and then add it as an operational layer. The last thing I want to show, which I'll jump into different code here. You guys actually saw this in the plenary if you attended that. Is a brand new feature called scene analysis, and there's two different analysis types. There's line of sight and view shed. This is really a graphics intensive real-time analysis that you can perform, basically looking at the visibility from an observer in a scene. So the first demo for line of sight, basically I've created some graphics at the tops of different buildings in Manhattan, and I have another graphic with a boat that's going along the river, and I can create this new analysis overlay, and then the scene view has a collection of analysis overlays, and to create the analysis we have a geo-element line of sight that will allow us to pass two different geo-elements, which are graphics or features. So I can do that from the boat to each of these buildings. And this constructor, or this object, is pretty nice because if those objects move at all, this will automatically handle moving the line of sight with them, so you don't have to track that yourself. So we just create these analyses and then add them to the analysis overlay. The last thing you can do with line of sight, which is pretty nice, is you can find out if the target is visible and then do something with that information. So there's a callback. So for each line of sight I created, I can add this target visibility change listener, get the target element, and then select it if it's visible. So I'll run this real quick. So it's going to take a second. And then, so as the scene loads, we have the lines of sight. The blue graphic over here is a boat that's traveling along a path. And then these are actually going to different buildings, which are going to start popping in. And notice that all the lines of sight are reporting that the target is visible, so they're green. And then because of that target visibility change listener callback that I gave it, it's selecting the elements when it changes to visible. So notice that as the boat travels around and buildings start to obstruct the line, then it dynamically tells you if the target is visible. So you can have lots of these lines of sight in a scene, and it will report the status very quickly. If you notice here, I can actually pan, and if it turns gray, it means that it can't detect if there's an obstruction. So we tell you that information as well. If we can detect it, it'll show us red for obstructed and green for visible. The last thing I want to show is the other type of analysis, which is viewshed. Basically, this is if you had an observer at a certain location and then they have a certain field of view, and you want to see what areas of the scene are visible. So here, here I actually have created a 3D model of a tank that's going to be driving around in the scene, and we can create a GeoElement viewshed, which basically attaches a viewshed to this tank. And we give some information about the field of view and the distance that we want to be able to see the visibility for. And you can also set an offset on these. So by default, the viewshed would be originating from the center of the graphic. But if you want to be on top of the tank or something like that, you can also apply an offset. And just like the line of sight, you add it to an analysis overlay to render it. So I'll go ahead and run this real quick. And once it loads, then we see we have a viewshed here coming off of this tank, and some buildings will start to load here pretty soon. And then you'll see that the viewshed will automatically adjust for those. Just give it a couple more seconds. Yeah. So I can actually tell the tank where to go, and notice that it's very responsive. It's taking full advantage of the GPU to calculate these. And you can have multiple these viewsheds at the same time. Now I've shown you the GeoElement variants. There's also a location variant of these viewshed and line of sight where you can just give a location for the observer instead of attaching it to a graphic if you prefer. You can also create a viewshed directly from a camera. I'll show that real quick. So here we start out from the initial camera location on a scene. And then there's going to be some buildings that will appear. This should be a bit faster than the other one. So notice that if you set the viewshed where the camera is, then you would expect that everything is visible to that camera because you can see it rendered on the screen. But notice if I pan, then I can see the areas where I wasn't initially able to see that from that camera position. And there's a simple constructor on the viewshed that's kind of a convenience constructor where I can just create a brand new viewshed, and then now, of course, those areas that are visible to the camera are now visible to the viewshed, and it's updated. So that's 3D analysis, and that's all the demos we have. Thank you very much.
Right. So any questions? Yep.
Yeah, with your offline tasks and especially with the pre-planned workflow, what kind of conflict resolution do you have in place when you go to upload back?
So it's almost like whoever last wins on the service. So yeah, like multiple users can still edit features. So whoever does the last edit, they would, like if they are editing the same area and the same feature, then the last one wins.
Do you have any plans to support maybe customizing that and which way we let the user determine how that works, or sort of maybe an emerging concept where is that possible?
I think there is something coming up on the feature service. Like it has to come from the platform as a whole. Like the feature services needs to support that. So there is something coming called branch versioning support for feature services, I think, which is probably would be available. So once the runtime leverages that, then probably somebody can like do these commits to specific branches, and then somebody at the desktop or at an office, somebody can actually use a desktop product and then maybe resolve any conflicts that arise from the different versions. Yeah. So it has to come like as a platform's workflow. Yeah. Any other questions? Yeah. Yes. So it's both, like for if you want to use it for mobiles, like you use the Android SDK. Like if you want to build desktop applications, you can use the Java SDK. Yes. Yeah. All right. Thank you.